Valence bond theory, Linus Pauling explained how the molecule is formed by the combination of the atomic orbitals together. The two atoms combine together and they form the molecule with the valence bond theory. A covalent bond forms when the two half-filled orbitals overlap to produce a new combined orbital containing two electrons of the opposite spin. This overlapping results in a decrease in the energy of the atoms forming the bond. The shared electron pair means the pair of the electron, it is occupying the space between the nuclei of the two combining atoms. Now let us consider the formation of a very simple homonuclear molecule, H2 molecule. H2 molecule is formed by the combination of the two different hydrogen atoms. Hydrogen atom number 1, 1s1. Hydrogen atom number 2 having electronic configuration 1s1. When both of them they combine together, there is a linear overlap between the two combining atomic orbitals of the hydrogen atom and there is a formation of a H2 molecule. Now, a covalent bond can be defined as it is a bond which is formed due to equal sharing of electron between the two combining atoms. This is the H2 molecule that is formed. Now, according to the valence bond theory, how many bonds are there can form the carbon? Means how many other atoms can be bonded with the single carbon atom? Now let us consider for that the electronic configuration of carbon. Atomic number of carbon is 6. So electronic configuration of carbon is 1s2, 2s2, 2px1, 2py1, 2pz0. According to electrovalent theory of any atom, the valency can be defined as the total number of the unpaired electrons present in the outermost shell, means the valence shell of the atom. In case of the carbon atom, the valence shell is the second one and the total number of the unpaired electrons present in it, they are the 2. That is the total number of unpaired electrons being 2. We can say that the valency of carbon is 2. But it is found that in most of the important compounds of carbon, for example methane, CH4, 4 hydrogen atoms are linked with the single carbon atom. It means that carbon should be tetravalent, having the valency 4. In the same way, in case of CO2 molecule, single carbon atom is linked with the two different oxygen atom by the double bond. Means the carbon is having the valency 4. So we have to prove how the carbon is not a divalent, it is a trivalent atom. So it can be explained on the basis of promotion of the electron. Now what is promotion of the electron? When these 4 different hydrogen atoms, they combine together, they come close to the single carbon atom. The energy of the carbon atom, it increases. And this increase in the energy is responsible for promotion of the electron from the 2s orbital to the vacant 2p z1 atomic orbital. So what happens now? The electronic configuration of carbon becomes like this: 1s2, 2s1, 2px1, 2py1 and 2pz1. Now let us count how many unpaired electrons are present in the valence shell of carbon, and they are 4. As there are present 4 unpaired electrons in the valence shell of carbon, we can say with confidence that carbon is tetravalent, having the valency 4. See here, this is the 1s orbital having the 2 electrons. This is the 2s orbital having the 2 electron. In the ground state, the electronic configuration is like this, but in the excited state, one of the electron from 2s is promoted to the vacant 2pz1 atomic orbital, and now there are 4 unpaired electrons. So now carbon becomes tetravalent. Now the problem comes, what is hybridization and what is the need of hybridization? Now let us think that the carbon atom is having 1s and 3p atomic orbital. If it is involving in the bonding as considering the s orbital and the 3p orbital, then in case of the methane molecule, the two different types of the overlapping will be formed. One overlap will be ss overlap, s orbital of hydrogen, s orbital of carbon, and the 3 remaining are sp orbital, sp overlap, one s orbital of carbon and the s orbital of carbon, and this s orbital of hydrogen and the p orbital of the carbon. So we can say with confidence that these two different types of the bonds that are formed, they are not having the same strength. But when the bond energy of the all the CH bonds is calculated, it is observed that all of them, they are having the same bond energy. It means that if for breaking all the CH bonds same energy is required, means the all the CH bonds should having the equal strength. And this point can be explained on the basis of hybridization. So what is hybridization? Hybridization is nothing but the mixing of the orbitals in their ground or the excited state, and then to form a new set of the hybrid orbitals which are identical in all respect, that is size, shape, only their orientation is different. So this is called as the hybridization. Now the shapes of the s, p, d and f orbital can be shown like this. S is spherical, p is single dumbbell, d is double dumbbell, and the f is like this. Now let us consider the formation of the methane molecule. Now we have the carbon atom having the 1s, 2, 2s1, 2px1, 2py1 and 2pz1 atomic orbitals. Now what happens in this case, carbon atom undergoes sp3 hybridization and it forms a set of the 4 sp3 hybrid orbital which are identical in all respect, that is size, shape and energy. Only their orientation is different, means they are oriented along the different angles with respect to the carbon atom origin. Now in this case, the carbon atom undergoes hybridization, getting the set of 4 sp3 hybrid orbital, and these 4 sp3 hybrid orbitals are oriented at the four corners of a regular tetrahedron with the bond angle 109 degree 28 minutes. Here it is shown 109 degree 5 minutes. Now this is the central nucleus of the carbon atom, and this is the first, second, third and the fourth sp3 hybrid orbitals of the carbon, which are oriented at the four corners of a regular tetrahedron. Here with the red line you can see the regular tetrahedron is shown. Now what happens when the formation of the methane molecule is to be considered? At that time, this carbon atom uses its 4 FOUR4 sp3 hybrid orbital having the single unpaired electron and overlaps with the 1s1 atomic orbital of the hydrogen atom, and then there is a formation of the 4 C-H bond. All of these bonds are the sigma covalent bond. They are formed by the linear overlap, and the bond angle HCH or HCH, it is exactly 109 degree 28 minutes. The methane molecule can be shown like this. This is the central carbon atom. Hydrogen, 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 hydrogen. They are oriented at the four corners of a regular tetrahedron with the bond angle 109 degree 28 minutes. All these bonds are the sigma bond. Sigma bond means what? When there is a linear overlap. Now what is linear overlap? When in that overlap the nuclei of both the atoms lie on the homo means the internuclear axis, then it is called as the linear overlap. And always whenever there is a linear overlap, it leads to the formation of a single sigma bond. So in case of the methane molecule, we can say that carbon is present at the center and the hydrogen atoms are present at the four corners of a regular tetrahedron with the bond angle 109 degree 28 minutes. All the CH bonds, they are sigma covalent bond. The structure of the methane molecule can be shown like this. Actually, this first figure shows the carbon atom and its 4 sp3 hybrid orbitals which are having the single unpaired electron. When the methane molecule is to be formed, at that time this carbon atom uses its 4 sp3 hybrid orbital having unpaired electron each and overlaps with the 1s1, 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 1s1 atomic orbital of the hydrogen atom, and there is a formation of the methane molecule. Methane molecule in this case, it is having the regular tetrahedral geometry having the bond angle HCH 109 degree 28 minutes. So this is the whole about the valence bond theory and the hybridization, regarding the sp3 hybridization and the formation of the methane molecule in details. Thank you very much.